So we are using Kaggle house price predictions data set for this. We have imported the data, train file and test file. Kaggle advanced house price regression, advanced techniques. Once you're done, please find the missing values. Use the original dot sum dot sort underscore values to find the missing values. Combined here dot is null brackets dot sum brackets dot sort underscore values within brackets ascending is equal to false. So in this case, we have to set the max rows. We will not be able to see the maximum rows, right? ed dot set option display because you are not getting the complete display of the rows, right? PD dot set option display max rows. Display dot max underscore rows. We have 81 variables, right? 81. Okay. Now we do the combined here dot is null dot sum dot sort underscore values ascending is equal to false. Now you can see the missing values in all the variables. All 81 variables you can see. Earlier you can't see them, right? There are dots in between and it will not be able to display all the rows. But once you have added the display option and set the maximum as 81, now you can see all the variables. Display max rows, comma 81. Now we can see all the variables, right? You can see all the variables with missing values and without missing values. As you can see, there are many missing values. There are many columns have missing values. Now, when you have this scenario of many columns having missing values, we have to split the data into object and numeric. Because object, we have a different strategy of missing value treatment. Numeric, we have a different value of missing value treatment. Now, let us split the data into numeric and object data so that we can deal with them easily. So num calls is equal to combine dir dot select underscore dtags include is equal to np dot number object calls is equal to combined df dot select underscore details include is equal to square bracket single quote object. Print num calls dot shape print object calls dot shape 81. Sum total should be equal to 81. Okay. So we have 37 numeric columns, 44 object columns or non-numeric columns in our data. All right, all of you are till this point. Okay. Any errors, please don't hesitate to call me. I'll come and sort it out. You have downloaded the data and imported it? Done? Now let us start with object calls. We will start with object calls. Find the missing values in object calls. Object calls dot is null dot sum dot sort underscore values ascending is equal to false. Missing values in object calls. Now, what do you observe here? The first five variables have huge missing values, right? Because the data size itself is 2009. We have 2090 missing, 281, 2721, 2341. And even fireplace quality is also to some extent, remember, you remember? What was the argument I said? Above 70% missing value, what we should do? Impute with the word missing. Because we can't do anything, we'll impute with the word missing or not available. Less than 70%, we can do mean, median, mode or imputations. So for the rest of the variables, if you look at the variables, these are very few. 159 of 2919 is hardly 5% or even less than 5%. If 10% is 291, right? 159 is less than 5%. So we have very few in other things that we can do anything. But the problem is with these 5 columns where we have big number of missing values. First one has missing values in larger thing. Fireplace, does every house has a fireplace? No, right? All houses will not have fireplace. So assuming that, we'll put this as missing also. Okay, but these 3-4 things, there is no option because there are more than 70% missing values. Right? More than 70% missing values, we should not impute, keep them as missing only. We should keep them as missing only. Okay, that's what we did in data pre-processing. When we studied less than 70%, we will try to impute with mean, median, or mode depending on the variable type. So let us first impute these 5 columns. Okay. For the purpose of that, just print the column names. Object calls dot columns. so that we can copy paste the names easily. And because more 90% of the errors are spelling mistakes only. Okay. So I will create a list. Missing calls is equal to, how will you create a list? Using square brackets. Missing calls is equal to, what are the alley, comma, pool QC fence, pool QC fence, comma, fireplace quality, and one more thing, which is the miscellaneous feature. Miscellaneous feature. Miscellaneous features means burglar alarm. Some houses will have burglar alarm. Some houses will have CCTVs. Like miscellaneous features or additional features which are not categorized under the existing variables, we categorize them as miscellaneous. So you can see next to fence only it is there, miscellaneous feature. So these are the 5 columns where we have big number of missing values. Okay. Yeah. No. You have to re-import the data and do it again. Access 1 will create, that is your full join. So that's not the. Just change it and run all cells. Just change it to access 0 and run all cells. It will automatically correct. So we will be using a for loop to do it. Okay, we will use a for loop. So this is the structure of for loop in Python. Okay, you have to first you give a what you call for x in or for y in or for whatever thing you can define in a list or a range. In a list or a range, you will have to define the iterations. Then you give the statement, and we have to give the end part, end block or the else block. And the statement also has to be given. Now, what we are trying to do here is we are filling the missing values in these columns. We are filling the missing values in these variables with word missing. Okay. So the loop is for call in missing calls colon, for call in missing calls colon. That is the standard syntax of for loop. Press enter, it will get the indentation. This indentation is very important. Once you press enter, it will go to the intended point. Object calls square bracket call is equal to the data frame name square bracket the iteration thing. Object calls square bracket call dot fill NA missing. So the statement we are saying here is iterate over the list of missing calls. Iterate over the list of missing calls and fill the missing values in the each iteration with the word missing. Iterate over the list. This is the list, right? Missing calls list. And then this is our data frame. In each iteration, the call value, first iteration, call value will be Ali. In the second iteration, the call value will be pool QC. In the third iteration, call value will be fence. Okay, like that, it will do 5 iterations and does the missing value imputation. Okay, now if I go up and run the null statement, now you can see all the missing values are gone. Now you can see all the missing values are gone. So the for loop, which will help us to impute missing values. So first create a list of variables for which you want to do missing value imputation. Then use the for loop. For loop is an iterative loop. In each iteration, it will take the list value as the input and will execute the statement what we have defined. Now here the statement we have defined is fill in a missing. What we have defined here is fill in a missing. It will do fill in a missing on each iteration for each variable. 5 variables, 5 iterations, and it will do fill it with the missing values with missing values with the word missing. So list-wise iteration. You can give list iteration or range iteration. Here we are doing list iteration. First, always create a list and then iterate over the list. This is the statement we are expecting it to do. Now, once you have done this, you can go and run the previous command. You can see all the missing values are gone. Okay. If you want, you can check the frequencies also. All of you have done this fill and name?
No, for these 5 columns, all the values are missing.
We'll see. We'll see. Okay, all of you are done with this? For loop? You want to see, instead of fill and a, give here value counts. Same statement, dot value counts. Then you will see the frequency of the 5 variables. Okay. So to see what it has done, for call in missing calls, column, object calls, square bracket call is equal, frequency is equal to, frequency is equal to object calls, square bracket call, dot value underscore counts. What is the function for frequency? Value underscore counts. And then print frequency. Now it has printed the frequency of all the variables. See, missing 2721, missing 2909, missing 2348. You can see the category has been added. You have done the earlier missing values? Error, okay, I'll correct. No problem. Now you can see, right? The category is created called missing. The category has been created called missing. You can do like this. So you can print the frequency of each variable in the list. One second. You can take the snap if you want for the other people, or else you can wait. So you can use for loop on range, list, tuple, dictionary, set or string. We are using it on list or array. We are using the for loop on list or array. So we created a list of variables and we are running the loop on the array. For call in, missing calls, column, then object calls call, a data frame square bracket call, and then fill in it. This is the statement it will execute.
Observation we are filling in the missing variable we are filling.
Observation. The empty cells are there in the column that is filled with the words. You have these empty cells, no?
Yes.
In alley, you have ending, right? These are filled with they are replaced with the words. Observations within that particular column or cells within that particular column will be replaced with the word missing. Because if you have an S, you can't run the algorithm. You have to replace the array with some value. No, you give it a warning. Now it's a warning. It's not a, because you're changing a big, making a big change, right? Now when this itself object comes on the top, will they vanish or not? When this shifted vanish. So the peak one is warning because you're doing a very major change in the data, right? That is what it is giving. Not all will be there. Sometimes there will be warning. What happened?
The coding input session, all input sessions, the input is about coding. Then I input 15 notes and input session.
Normal copying is, you just need to copy it. You can just copy it like Control C, Control V. What is our okay? All right, we move forward. What are the next set of missing values? Garage. The next set of missing values, if you scroll up, you will see garage, right? Garage count, garage call, garage finish. Now create a list called garage calls and print the value counts. Instead of missing, first create a list called garage calls with the variables and then print the frequency of the garage calls. This loop, instead of missing calls, create a list of garage calls for which you have missing values and then print the frequencies of the garage calls.
Take the least damage column. That four values are damage, damage. And then everything,
Got it?
damage column.
Hmm.
Least way of
Garage calls, just like how we run it, the frequency on missing calls, you have to do the same thing on garage calls. So garage type, garage fin, garage call, and garage condition, right? All of them are in same. That's what all are in simultaneous only, right? Paste them here, right? All of them are simultaneous columns only. Okay? For call in garage calls colon, frequency is equal to object calls square bracket call dot value underscore counts. Oh, sorry, I forgot to print frequency. Print frequency. Oh, sorry, we have to add drop NA is equal to false. So first create a list and then run the same command like how we run the frequency command. Dot value counts drop NA is equal to false. Now you can see the first variable is garage type. It has 157 missing values. It has 157 missing values. Now already a larger category is there attached. 1723. By adding this 157 to this, will it make any difference? It does not make any difference. Similarly, if you look at the second variable, garage finish, there are 159 missing values. Already unfinished is 1230. By adding this 159 to that will not make any difference. Similarly, the third variable garage quality, missing values are 159, TA 2604, by adding that 159 to that TA does not make any difference. And the last variable also, garage condition, TA, again 2654, it's a huge thing. So in this case, what we can do, we can impute with most frequent or mode. For all these four variables, I want you to observe each and every variable and then decide. Okay, look at the frequencies. What you have to decide is, can we impute with mode or not? Or most frequent. Mode is nothing but most frequent. Just look at them and then decide whether the four variables can be imputed with mode or not. They can be imputed with the mode. Now, the next set of missing values are in basement calls, right? Next set of missing values are in basement calls. Now run the frequency of basement calls. So what I'm trying to do is, if all of them can be imputed with mode, we can do it in one single iteration. So before that, so now we have checked garage calls. We found out that all the variables can be imputed with mode. Now let us check basement calls. Because rest of the things we can impute with mode. They are very small, 1, 1, 24, nothing. Blindly we can impute them with mode. Now I want you to check basement calls. All the basement condition, exposure, call, fin type 1, fin type 2. Create a list of BSMT basement calls, like how I created for garage calls. Print their frequencies and then decide. If you decide all of them can be done, we'll go in one single iteration, the missing value imputation, so that we can avoid duplication. Create basement calls list and then run the same for loop for frequency. Can you do it more? Copy paste the names from the list, columns list. Okay. Please do not type, copy paste from the columns list. Done. So most frequent you can do. So I'll create a list, BSMT calls, basement calls, and you can give any name. Okay, naming is your choice. You can give A, B, anything you can give, but preferably the one which gives you the representation of the data is best, so that it is easily explainable or self-explainable to the other person. If somebody else is working, you will also know it. So we have all of them in simultaneously in one location, right? Control C. Here's them here, Control V. Going down. Now, for call in BSMP calls, column, frequency is equal to object calls, square bracket call, dot value underscore counts, drop name is equal to false, so that you can see the things and then print frequency for the output. Now we got the basement calls. Missing values are 81, 1283 is there, we can add it to that. Missing value 82, 2606, we can add it to that. Missing value 82, we can add it to 1904. 79, we can add it to 851. 2493, we can add it to 802493. Okay, and rest of the missing values are very small. 24, 1 and 1, they are nothing. 4, 1, nothing, right? Okay. Now, we will fill missing values in all variables of object calls. Okay. For call in object calls dot columns. Now object calls dot columns will create a list of names. List of names, right? It will create the list of variable names. Object calls square bracket call is equal to object calls square bracket call dot fill na object calls square bracket call dot value counts dot idx max. So you can type in straight line. I am typing for your reference in 2 lines, but you can type it in straight line. So what we are trying to do is we are first creating the frequency table. We are first creating the frequency tables. Okay. Value count is what? Frequency table. Like this, we'll create a frequency table. Now in a frequency table, this is called index or IDX. This is called frequency. In a frequency table, this is called IDX or index. And this is called frequency. Now IDX max, that means we are finding out the max index of the max. IDX max means index of the max frequency. We have to replace with the word, not with number. So we have to replace the missing value with the word UNF. Right. So IDX max means index of the maximum frequency. What is index? The text of that thing. So that is what we are doing. First, we are printing the frequency table. Then we are identifying the max value. And then we are also identifying the index of the max value. So IDX max means index of the maximum frequency. Now, if I run this, now I go back to the top and run this missing values thing. Now you can see all the missing values are gone. So for each missing value variable, it will run the value counts and then identify the IDX max and fill the value. See, one single iteration, we've completely filled all the columns. So fill NA, first create the frequency table, then find the index of the max. And it will replace the index of the max in the corresponding tables. And fill NA will touch only the missing value cells. It will not touch any other cell which does not have missing values. It will only touch missing value cells. IDX max. IDX max, index max.
So like object construct column is all one of the object that will be there selected, right? All will be.
Yeah.
Then object for, okay, we are doing that,
Frequency counts.
okay.
And then we identify the maximum value of the each tables, each frequency tables, ID of the maximum frequency. So, see, it will iterate over all the columns and it will find the columns that have missing values. And then on those missing values, it will create frequency tables like this. In the backend, it will create a value counts means what? This is the output of value counts, right? And then what is the ID? We don't want the number, we want the category. So this is the maximum. What is the index of the maximum? UNF. So the missing value should be imputed with the word UNF. The missing value should be imputed with the word UNF. With UNF, yes. Wherever NA is there in the basement pin type 2, it will be replaced with UNF. Now you can see here, pin type 2, right? So what is the UNF number? 2493, right? 2493. Two four nine three became 2573 because 18 cells which are missing values that have been replaced with the word UNF. Then only you can count as 2573, right? And there are no NANs because I have said drop N is equal to false. There are no missing values here. You got that logic, right? So it has to create a frequency table, identify the maximum frequency, then the index of that maximum frequency will be the missing value replacement. Yes. So what it will do is, it will first segregate the columns in the back end, missing value columns and non-missing value columns it will segregate, and then on the missing value columns only it will work. Non-missing value columns, it will not touch. But only applicable on missing value cells. Fill and net does not touch any variable or column which does not have missing values. Got it? So we have completed the missing value treatment in object calls. We have completed the missing value treatment in object calls. Then what we should do? We have to convert we'll do the label encoding also. Label encode the object columns. What is label encoding? Dummy variable encoding. And since we have less number of observations, it is better to use label encoder rather than get dummies. Because that get dummies will create hundreds of columns, right? So we have very limited data. Only 1,460 rows are there. Already we don't have enough rows. We have 80 variables, right? 80 into 20, we should have 1600 rows. Already we have less amount of data. By adding more variables, it will create more problem to our data. So here we are preferring label encoding. Here we are preferring label encoding. From sklearn dot preprocessing import label encoder. LE is equal to label encoder. Object calls dummy is equal to object calls dot apply. LE dot fit underscore transfer. All right, so we got an error. acha, sale price. Ah. Okay. Before we run the label encoder, we have to move sale price is there, na, which is a mixed data type. Integer and string is there, na? We have to move it to num calls. Num calls square bracket sale price is equal to object calls dot sale price. Okay. Move sale price as it is mixed type. Mixed data type. What mixed data type? Float and string. Now we have to drop it. Object calls is equal to object calls dot drop sale price comma axis is equal to 1. Now this will work perfectly well. Dummy variable encoding. That is what we are doing, so that we have complete object calls pre-processing done with dummy variable encoding. So actually what we have done is object calls dot head. This is our text data. Okay, this is our text data. Right? Object calls dot head, this is our text data. Object calls dummy dot head will become numerical data. Numerical identifiers. So object calls is text. Object calls dummy is numerical identifiers. Data has been converted into numbers. These are numerical identifiers which are there for each and every text variable or categorical variable. Okay, now find the missing values in numeric calls. Num calls. So this is the procedures you need to follow. Object columns is preferably the first one you should always target, because that is the complicated things where you will see categorical issues, all those things. So start with object calls. Some people will start with numericals, nothing wrong with it. But numericals are easy to manage compared to object calls. So the difficult one you start with first and then go variable by variable. Now by doing this process, we understood the various variables. We have variables related to garages, we have variables related to basements, We have variables related to fence, alley, house, miscellaneous features. So this data pre-processing not only helps us to process the data, but also gain understanding of the variables. So that is the important thing. By printing the frequency counts, we are understanding the variable structures, whether there are too many categories or not. Here there are no too many categories, right? All of them are limited categories only. Okay. Can we move forward? Num calls dot is null dot sum dot sort underscore values ascending is equal to false. We have missing values in lot frontage, garage year built, mass VNR area. But we also have some categorical variables in the numeric variables. Like I told you, years. Years cannot be treated as numbers. See here, garage year built. Okay, then if I scroll down, you have variables like, see, month sold, year sold. Then you have variables like year built, year remodeled. In which year the house was built, which year it was remodeled, and overall condition and overall quality, which are your rating scales. Just go through the data dictionary. You will come to know what I'm talking about. In the data description, you can see here, see, year built, date. Year built is dates. That cannot be treated as number. It will be number 1978, 1980, 1960. Year remodel, remodel date. Okay, and then if you scroll down or control F, MO sold. See, month sold, year sold. Both are dates, right? And one more thing, mass VNR type, that also has missing values, right? Mass VNR area has missing values, right? Missing values are there in VNR area or VNR type. VNR area has missing values. That is okay. That can be treated as numbers, right? Now, what is the other one? Lot frontage. What is the variable type of lot frontage? Linear feet. Okay. It is also numerical variable only, right? It is only numerical. So what we have to separate? We have to separate years, and let us look at the overall conditions also. See, overall quality is a rating scale, 1 to 10. Overall condition is also rating scale 1 to 10. So we have to separate from numerical variables, categorical variables. Which are those categorical variables? Typically dates, typically rating scales. These have to be separated from numeric calls. Okay, so let us separate them from numeric calls. So first print the column names, num calls dot columns. Okay. So cat calls is equal to num calls double square brackets. Now we have these variables MO sold, year sold in the bottom, copy them, paste them, comma. Then garage year built is also here. Control C, Control V. Then year built, year remodeled. Oh, okay, we have all them simultaneously. Overall condition, quality, year remodeled and year built. Any other variable we have which might be categorical in nature? Subclass, lot frontage. MS subclass. Look at MS subclass. I think MS subclass is also categorical. Yeah, MS subclass is also categorical, right? The first variable. It is having one story, 2 story, like that. It has the code identifier is there. So MS subclass also has to be treated as what you call categorical data. So that also we have to move to this one, MS subclass. Right? These are our categorical variables, which are there in numeric variables because of the data type being integer. Because of the data type being integer, they are coming in the numeric calls. We are separating them. Oh, why we got this error? Forgot comma. Okay. Now immediately drop them from num calls. Num calls is equal to num calls dot then square bracket to square bracket, single square bracket to single square bracket, comma, axis is equal to 1. So separate them and delete them. Immediately, in the very next step, delete them. So print object calls dummy dot shape, print cat calls dot shape, print num calls dot shape. 43 plus 8 plus 30, 81. We have 81 variables. The number should not change. Fifty, 30, yeah, 43, 8 and 30. 81. Okay, whenever you do any major change to the data, always print shape and check whether because the columns should be 81. Sometimes what happens is I have seen very silly mistakes that columns, they didn't duplicated columns were there, the data shape completely changes. Now that's a major problem. So to avoid this, whenever you are doing a subsetting or when you are doing a slicing or changing or something, sorry, applying on data, you always print the shape to check whether the data is correct or not. If there is any error, you can correct then and there and you can rectify the errors. Now, I think garage year built has missing values, right? 159. 159 garage year built has missing values. So we have to treat it as categorical, right? So cat calls dot garage year bill dot value counts drop NA is equal to false. So we have 104 different years. We have 104 different years. Missing values is 159. 2005 is the most built year. 2007, 115. So what should we do with these missing values? Should we keep it as missing or should we add it to 2005? We'll keep them as missing only, right? Because not above 70%, but the problem is they're very close. 142, 115, 115, 99 and all, right? We can add it to 2005 as a building year also, or we can keep it as missing. Now missing means this is a numerical type variable, so we have to do a numerical encoding. Like 999, something different which is not there in the value. Or shall we add it to 2005? What do you say? Because it does not make any effect, it does not affect the data much. It's a very small missing category. It might not affect the data as much. So shall we add it to 2005 or shall we create a numeric code, missing numeric code? Yeah, we will create a code. So the numeric missing code, like if you are an object, we use the word missing. But if it is numeric data or if it is in the format of a numeric, we can't use the word missing because it becomes a mixed data type. So what we have to do is we have to create a numeric identifier for missing. Now that numeric value should not exist in the existing range. So we have data from 2005 to 1990. I'm sure that 999 will not be there. 4 nines will not be there. So we will impute it with 4 nines. That would be the safest numerical encoding.
If we are adding in 2005, data can be managed.
That's what we are assuming, and that's why we are creating a new missing code called 999. Because we can't use the word missing here, we have to create a code which is 999. So cat calls dot garage year bill is equal to cat calls dot garage year bill dot fill NA 999.0. Because the existing is 2005.0, we'll keep the same data structure. It is giving a warning. Let us see whether it worked or not. See, 999.0 is the missing code we have added, and it has given me a warning because we are doing a major change. Okay. Now num calls, we have very few missing values, right? Num calls, we have very few missing values. A lot frontage, mass VNR area, base empty, full bath, half bath, garage area and all. So we will do median imputation. To be on safe side, we can do median imputation. Median imputation for num calls missing values. For num calls missing values, we are going to do median imputation. Here we are encoding with missing code 999 dot 0. For call in numcalls dot columns, we are creating a list. Numcalls square bracket call is equal to numcalls square bracket call dot fill na numcalls square bracket call dot median. Acha, we have again the problem of okay, that sale price is there, na? That we have to look at it. So we'll move it back to object calls. Or we'll create Y. We need it for segregating the data. Object calls dummy square bracket sale price is equal to num calls dot sale price. Num calls is equal to num calls dot drop sale price comma axis is equal to 1. Now it will work. Dummy object dummy, because we need to segregate the data, right? See, as you gain experience, you will use row numbers. But the thing in Python is the row number count should start with 0 and the outer value is ignored. So if you want to select 1459 rows, 0 column 1460 you have to give. People miss that. And then they give 0 column 1459, the data structure will change. Till you gain confidence in row indexing correctly, use this method of adding a test and use test to separate. Equal to test, not equal to test, you will not have an error. But generally what happens is we will use row numbers. But Python starts with 0 and outer value in the index will be ignored. So if you want 1459 rows to be selected, it must be 0 column 1460. Right. So that is very important here. So if you miss that, your row number structure will change. Till the time you gain confidence and once you understand the row structures and all, you have to use this test and we have to constantly move that because it's a mixed data type. If you are trying to apply anything on a mixed data type, it will give an error. So we have to remove that or put it in a say, add it to some other thing so that the mixed data types does not arise. Okay. Otherwise, once you gain proper experience, you can use row numbers. You can initially separate it as Y and drop it from your train data itself. And then you can merge train and test. And then there is no problem. Segregate it as a Y and drop it from train data and then you can combine. So that can be easily done. But till you gain the row number confidence, you have to use this test. Equals to test, not equals to test. That way your chance of error is 0. So we have imputed the missing values in numeric calls with median. We have to label encode cat calls. Cat calls has to be label encoded, right? Which you have separated from numeric calls. Cat calls dummy is equal to cat calls dot apply le dot fit underscore transform. Now we are doing the dummy encoding of category calls also. Okay. Now we will combine df underscore clean is equal to pd dot concat square bracket num calls, comma, object calls dummy, comma, cat calls dummy, comma, axis is equal to 1, row column wise concatenation. Combine df underscore clean. Two nine nine one, 2919, 81 variables. Right? Now we will split it back to our normal data. Huh? You've not done it. Is equal to test, not equal to test, house train df and house test df. Make sure you're concatenating the dummy columns. Done? You can take your break. We'll continue after the break. Okay? Ready. So post break, we have done exploratory data analysis, split the data into Y. Then we have changed the data type of Y from object to float, descriptive statistics on Y, histogram, box plot and density curve. We found positive skewness. We have done logarithmic transformation on the dependent variable. When we checked for multicollinearity using correlation and C-bond, multicollinearity for C-bond. Now we are doing the hypothesis testing, where we have done the mean and we also have done the variance. Mean is different, variance is different. Now let us write the null. Null is no significant difference in average sale price of different street. There is no significant difference in average sale price of different street. Copy and paste the same statement, change the null to alternate and remove the word no before significant. No significant difference means you can treat them as equal. Significant difference means you cannot treat them as equal. The null hypothesis is no significant difference. No significant difference means both means can be treated equally. We are not talking about numeric equality. We are looking at statistical equality. Whether we should treat the means equally or not. Null says you can treat them equally. Alternate says you should not treat them equally. Now you have to split the data. Now we have to split the data. So what is gravel? Gravel is equal to house trained year, square bracket, house trained year, dot street, double equals to 0. Paved is equal to house trained year, square bracket, house trained year, dot street, double equals to 1. We are splitting the data into gravel as one data frame, paved as one data frame. Okay. So Grable and paid 0 and 1. All of you split. Now what is the, go to scipy.stats. Scipy.stats. What test we have to do? Independent sample t-test, because there are exactly two levels. So t-test, this one. Calculate the t-test for means of two independent samples. T-test underscore int. And this is the thing we have to give. Equal underscore variance is equal to false. By default, it is taking it as true. From scipy.stats import t-test underscore end. T-test underscore end gravel dot sale price comma paved dot sale price comma equal underscore var is equal to whatever. Data type class numpy object not intact. String here dot sale price dot D type is showing as object. So we have to change this also. House train df dot sale price is equal to house train df dot sale price dot as type. So we have changed it as X, not as the data. So we are changing the sale price type to float 64. Then we get the data, t-test. Now it is float 64. Now it will run. So first change the data type to float. House rent df to sale price, change the data type to float 64. Then run the next command, Gravel and pave. Okay. Then you split the data and then run the test. Now the interpretation based on the p-value. So what we will do if it is greater than 0.05? Fail to reject. Less than 0.05 is reject null. Here we are failed to reject null. Fail to reject null. That means we are accepting the null hypothesis. That means there is no difference between both the means. You can treat them as equal. Okay. Rational, the average mass VNR area. Of different street equal. So all you have to do is group by mean and variance, null and alternate. There is no need of splitting the data. Data is already split. So first find out the mean difference and variance difference. Then write the null and alternate. Then directly conduct the test. Because data is already split into gravel and pave. First find the mean difference. Group by mass VNR area. Is the mean different? So outstrain df dot mass VNR area dot group by outstrain df dot street dot mean. 55 and 103. Do the variance also because we have to use that equal underscore var, right? Dot var. Variance is also different. Now write the null and alternate and then conduct the test. You can copy from top null and alternate. Average mass VNR area mass VNR area. Just change the sale price to mass VNR area. And conduct the test. It's still updating. The contact may be object person of the class. Only one you have to do it. It is only two groups. It is very, very low the group. That will come, you have contact with both together. So you got one group for us. This is the problem. And it is, there are two groups. It is not able to identify the total information. So what is the rejection? Fail to reject or reject? Fail to reject, null. So p test underscore n travel dot mass VNR area, comma, paved dot mass VNR area, comma, equal underscore var is equal to false. Since p value is greater than 0.05 is greater than 0.05, we fail to reject null, which is nothing but accept null. But we should not use the word accept. Right? Now, we have done a couple of t-tests. Now, let us see some ANOVA. ANOVA, what we have, land slope. We will do it on land slope. Slope of property. GTL mod severe slope, gentle slope, moderate slope, and average slope. First null, the average sale price of different, what is the variable name? Land slope. Different land slope equal. Okay, so here you have to do group by mean only because there are more than two levels, right? There are more than two levels. So what we have to do? We have to use ANOVA single factor. Exactly two levels, t-test. T-test independent sample. More than two. It can be 3, 4, 5, 10, 40, 50. You have to use ANOVA single factor. So for ANOVA single factor, you have to do group by mean only. No need of variance. Group by mean, then null and alternate, then split data, conduct test, and infer based on p-value. P-value less than 0.05, reject null hypothesis. P-value greater than 0.05, fail to reject null hypothesis. Fail to reject null hypothesis is nothing but accept null. But we should not use the word accept in statistics. It has to be reject null or fail to reject null. Less than 0.05, reject null. Greater than 0.05, fail to reject null. 0.05 means 95% confidence level. 0.05 means 95% confidence level, 5% error or alpha. Means are different. Closer. Okay, no problem. They are different, right? They are not exactly same. So house train deer dot sale price dot group by house train deer dot land slope dot mean. They are not same, they are different. Means are different. 0, 1, 2. Let us see. GHIJKLMNOS. Okay, GMS 0, 1, 2. 0 is GTL, which is gentle. 1 is moderate. 2 is severe. Alphabetical order. Gentle slope, moderate slope, and severe slope. Now split the data. Split the data into 3. GTL is equal to house train deer square bracket house train deer dot land slope double equals to 0. Mod is equal to house train deer square bracket house train deer dot land slope double equals to 1. Severe is equal to house train deer square bracket house train deer dot land slope double equals to 2. Okay. Gentle, moderate, severe. The function is f underscore 1 way. SciPy dot stats f underscore 1 way. Okay. Reject null huh? Or fail to reject null. From SciPy dot start. SciPy dot start is part of NumPy. Import f underscore 1 way. F underscore 1 way is ANOVA single factor. ANOVA is F distribution. Remember, t-test is T distribution. ANOVA is F distribution. Chi-square test is Chi distribution, CHI. So F underscore 1 way is ANOVA. All you have to do is F underscore 1 way GTL dot sale price, comma, mod dot sale price, comma, GWay dot sale price. Oh, again failed to reject null. Zero 0.05 will fail to reject null. Okay. Now do the same thing for mass VNR area. test null, the average mass DNR area for different land slope equal. So data is already split. All you have to do is group by and conduct the test. Group by, yeah. One or 3, 89 and 78. P value greater than 0.05. Okay. Now let us do some chi-square tests. Huh. 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 No, group by these are not interrelated. But this is a procedure. They are not interrelated. They are completely different. There is no relationship between f underscore one way and the group by functions. The process and the procedure. What hypothesis testing says is the means must be different. That is a fundamental assumption. So you have to verify that assumption. How will you verify using the group by function? So without verifying it, you can't do the test. That is the statistical procedure and the process. There is no relationship between both the functions. Test null, no association between street and land slope. Test null, no association between street and land slope. Both are what variables? Non-numeric categorical variables. For non-numeric categorical variables, we have to do chi-square test of independence. The input is crosstab. PD dot crosstab, house train df dot street, comma, house train df dot land slope. We have the cross tabulation. No association is null hypothesis. Association is alternate hypothesis. From scipy.stats import chi2 underscore contingency. Chi2 underscore contingency is the function for running the chi-square test of independence. Chi2 underscore contingency, you can copy paste the cross tabulation function. Control V. And run the test. This is the p-value. We will reject null. What is null? No association between both variables. Alternate is association between, there is association between both variables. So we are rejecting the null hypothesis. That means there is a relationship between street and land slope. There is a relationship between street and land slope. This is the p-value. E minus 11. E minus 11 means 0 point after 10 zeros. The value will start. So it's far less than 0.05. So E minus 11. So here we are rejecting the null hypothesis. There is a relationship between street and land slope.
Can you repeat
E minus 11 means it is far less than 0. See, this is the value we got. See, after how many zeros the value is starting? One after 10 zeros, the value will start. E minus means it is less than 0.05. You can assume. E plus means it is in billions or millions. E plus is greater than 0. E minus is less than 0. So this is the actual value, which is shown as 3.32 E minus 11. Okay, so we will do one more chi-square test. Let us see which variables are suitable. Mass VNR type and exterior quality. Mass VNR type and exterior quality, right? Test null. No association between mass VNR type and exterior qual. This is the word exterior qual. So I closed it. Huh? Why did I close it? Exterior Q capital. EXTR Q capital, yeah. PD dot cross tab house train df dot exterior quality, comma, house train df dot mass VMR type. This is the cross tabulation we got. Now do the chi-square test. Is less than 0.05. P value is equal to is less than 0.05. We reject null, which means what is the null? No association between both variables. If you are rejecting the null, you accept the alternate, which is relationship between both the variables. So exterior quality and VNR type, there is a relationship. There is a relationship. Now we have completed our exploratory data analysis. We have studied our variable types and all. Sign it, name and sign. Okay, now we are ready to build our model. We are ready to build our model. From sklearn dot linear underscore model import linear regression. Reg is equal to linear regression. See, model building is very simple task, hardly 5 seconds. But see, last 3 hours we were processing, understanding, all this thing is the time consuming. That's what we say. 95% of the time is data pre-processing and understanding variables. Only 5% is model building. So we are studying last 3 hours to bring the data to a form where we can build a model. Reg model is equal to reg dot fit x comma y. Reg model dot score x comma y. 85.44 is the R square we got. We got 85.44 as R square. So R square is in range 0.60 to 0.95. It is in the range. Reg predict will create the equation reg model dot predict of X. Reg receipt is equal to y minus reg predict. np dot sqrt, np dot mean reg receipt to the power of, oh sorry, star 2. 30,300 is the RMSE. We are getting RMSE of 30,300. We are getting a RMSE of 30,300. Okay. Okay. But this is a competition data. We have a test data to predict, right? We have to predict on test data also. Since this is a competition data set, we have to predict on test data. House test df is equal to house test df dot drop ID. We have to drop the ID column. Access is equal to 1. Just drop the ID column. Okay. Reg test predict is equal to reg model dot predict house test here. So we got the predictions for the test data. These are the predictions for the test data. We didn't have the dependent variable in test data, right? We didn't have the dependent variable in the test data. Now these are the values for the dependent variable in the test data, which is predicted using the trained data model. Using the trained data model, the equation is created, and using that equation, we are predicting for test data. So these are the values which are predicted for test data. See house test df. Now pd dot data frame reg test predict dot to underscore csv reg dot csv. So I am writing it to a file, CSV file. I am writing it into a CSV file. So first we predict on the test, we drop the ID column, then we predict on the test data, we got the predictions. I am writing it into a data frame and writing it into a CSV file. Okay, so whatever folder you have attached in the top, in the folder, a CSV file will be there, reg.csv. You have to copy the values under 0. Don't copy the 0. I will show you now. Once you have done the prediction, you go to this site. So my data is stored here in house price prediction. Today at 12:27 reg.csv, right? Now open with Excel. These are the predicted prices. And I asked you to download the sample submission also, right? From the website, you have the sample submission file also. open with Excel, sample submission file has the IDs and the sale price. Do not touch the IDs, do not touch the sale price. From here, you have to paste the data. So go to your original Excel sheet, copy from 0, do not copy 0. Control Shift down arrow, Control C, under sale price, paste them, Control V, Control S. Save them, okay. So don't touch the IDs, don't touch the sale price, keep them as it is, and don't copy 0 from the file. Below it, you copy the files. Now, once you have done this, you are ready to submit in the competition. If you go submit predictions. In the submit predictions, you have to upload the CSV file. House price prediction, sample submission.csv, open. See, it is uploading the file. Once it is uploaded, sample, you will get it. Now, you can write MLR, multiple linear regression, make submission. So, it is saying my score is 0.35612. 0.35612. There are people who are with 0, close to 0 also. They have built advanced models. But this is, my score is 0.35612 because we have used a basic algorithm. But my best entry is 0.16880. Okay, 0.3562 might be around 4,000. It will be around 4,000 rank you will get. You can submit it. But my best score is 0.16880. We will try to improve the score as much as possible closer to 0. Okay, so 0.35612 will somewhere be around 4,000 or something will be there. That will be the score. Then we will build advanced models. Like the competition itself says, advanced regression techniques. We are using the basic model now. So basic model obviously will have a less accuracy. So we will be using advanced regression techniques. So here saying here, right? Feature engineering. Feature engineering means what? Data pre-processing. The other name of data pre-processing is feature engineering. Features means variables. And then he is suggesting random forest and gradient boosting. Random forest and gradient boosting. Tree-based models will work better on this data than the base model. Our scores will drastically improve. I got 0.35. If I use decision tree, it goes up to 0.20. Random forest gradient boosting, it may go up to 0.13. Like that, your score will improve as we go deeper into algorithms. Okay. So this is the process of submitting into the competition. Write the file into a CSV file, copy the data into sample submission file. And once you got the data into sample submission file, you can upload it into the competition site and get your score. You can do 10 submissions per day. Same thing with Analytics Vidya. Sample submission file, you can replace the predicted values and upload in the competition site to check your model performance. Upon where we are predicting predicted values. Python does not automatically predict the values. In Excel sheet, we got the predicted values automatically, right? Here we are doing the predicted values. These are predicted sale price. Because if you remember Excel sheet, we need predicted values, right? Then only we can calculate residual. What is residual? Actual sale price minus predicted sale price. So this predict function will help us to get the predicted sale price for all the observations in our trained data. And then we are calculating the residual. And using that residual, we are calculating the RMSE.
Why is the
Dependent variable.
dependent?
Ah.
X means that all the individual.
All the independent variables.
So based on the X, we are predicting.
Just like that, the equation I showed you now in Excel. It will use the intercept and the coefficients and use the same X data. Our train data one called row one, row two, and it will do the predictions. It's like how we did in Excel, na? Same process it will follow.
Since here the mean is like based on the X values, we will predicting.
Y. Y predicted Y. Now here we are using test data, which is again independent variables without the dependent variable. We are predicting on test data to check the accuracy of our, how accurately we are predicting our model. Okay, here we are predicting on train data itself. Because we need a residual, right? Without residual, we can't calculate RMS. Got it? Up or down? Hmm?